All right, everyone. Let's start off with the first topic of our computer science IGCSE or O level syllabus, the data representation topic. Now, before starting off, I want to clarify that this topic is a bit boring, but it's the foundation behind everything you learn and see in computer science. So, just a moment, just a second. Let me see if my screen. Just a moment. Okay, okay, it's fine. Okay, so the first topic, data representation. Now, when we do counting or something like that, we always have the numbers in our mind, right? So if I want to count it 10, I'm like 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We have 0 to 9. There are these 10 digits which we can represent. Those are basically 0 to 9. These are our conventional numbers. Conventional numbers. Like, let's say I say that, tell me how many kids are there in the class right now. Maybe someone can say that we have around 9 kids right now. Yeah, yeah, you can take notes. Okay, I will. Oh, guys, the light just went off. Let me turn off. बल्कि सही है, मौसम इसी तरह से. Yes. So we have. Okay, just a second. Chalo sahi. Okay, so we basically have these 9 digits. Okay, yeah, exactly. We have these 9 digits in our conventional counting, 0 to 9, right? So, like, if I want to count how many students are there in the class, let's say we have 10 students right now in the class. These 10 are basically numbers from 0 till 9. Yeah, sorry guys, sorry. There was a bit of internet disruption. I don't know why. Again, is my audio audible? Can you guys hear me? Yeah, chalo, say. Let's start off. So I was talking about computers, right? So the first thing you all need to understand is that a computer or whatever hardware you guys are using, that has been created using circuits. See, we have different sort of circuits which operate together to create the hardware which we have today in front of us. Maybe for me, it's my laptop. For you, it could be your computer screen, your PC, phone, whatever device you are joining the class from. This hardware operates on circuits. And how do these circuits work? Let's take a very, very simple example. You see, I believe you all are studying physics, right? Let me know in the chat. Do you guys study physics? Yeah, you guys do. So basically, what happens is that in physics, you will be studying this chapter known as electronics. Okay. So what's in electronics? You have a circuit. Basically, let's say we have a switch up here. Ignore the bad drawing, but let's say, and then we have a bulb up here, electric bulb, and then we connect it back from here, right? So when I want to turn off the switch, in other words, I want to turn on the lamp, what is going to happen? If I switch this, like bring it to this point, what's going to happen? We are going to be having light up here, right? But as soon as I remove the switch and I turn off the lamp, what's going to happen? The light is just going to go away. Now, what happens up here? You have two conditions. One is turning on, and the other is turning off. Now, the issue with computers is that electronic devices or these circuits have only two states. You could either be turned on or you could be turned off. There is no third state or a state in between where you can do something else. So either you need to turn on something or you need to turn off something. So in computers, in terms of computers, when you want to turn on something, it is denoted by the term 1. And when you want to turn off something, you say 0. Now we are going to be diving deep into the main concepts. Now, before moving on, I want to ask, what's binary in your opinion? Like, we are going to be studying binary. Tell me, what do you guys think? What's binary? Base to number system. Okay. Hmm. Okay, you don't know. No worries, no worries. We are going to be studying that. Okay, so basically, binary is the computer system, is the numbering system which the computer understands. So, as I mentioned earlier, we understand numbers from 0 to 9. Okay, we can do maybe 75. What's 7? It's from the first 0 to 9 numbers. What's 5? Again, 0 to, it's a digit from 0 to 9. But a computer cannot understand 7. It does not understand 7. So, computer, as we said, computer only understands two states. Understand two states. You either have an on state, you either have an on state, which is basically referred to as one, which is one, or you have an off state, which is basically off state, which is basically a zero. Now, if I go back to the same example which I mentioned earlier, we said that turning on is one, whereas turning off is zero. Now, you would have seen these numbers zeros, one, zero, one, one, zero, zero, one, one in those tech-related movies or articles. Maybe sometimes people feel like exactly the Matrix, and sometimes in those articles you feel like, oh, this is something related to hacking. Well, it's not related to hacking. This is basically the numbering system which a computer understands. Now, how does a computer operates with these numbers? Now, let's say I have this lamp, okay? I want to create a program, but I want to say that when I press the A button on my keyboard, it should turn off the lamp. But when I press the S button on my keyboard, it should turn on. Now, what happens? Basically, I program my keyboard in a manner where I train that the A button should tell the computer that I'm trying to press 1, whereas the S button means that I need to be going with 0. Now, let's say from this example, if I press A once, what's going to happen? The light is going to turn on. But as soon as I press the zero S button, what's going to happen? The light is going to go away. So a computer can only understand one and zeros. But the whole thing is that a computer operates at a very large scale. So you have like millions of such circuits in your computer. Maybe if I say that circuit number one, let's make it up here. If I say like circuit number one, if circuit number one is on and circuit number two is off, circuit number two is off, then you need to print onto the screen, print 3. So now the computer is going to see when I turn on circuit number one using, let's say, A on the keyboard, and then I turn off circuit number two using the button S. For instance, this is just like an example. It's nothing practical. I'm just trying to explain the concept. If I press A and then I press S, the computer is going to see that circuit number one is turned on, whereas your circuit number two has been turned off. Now, once the computer gets to know this, what's going to happen? It will print 3 onto the screen. This is the very basic concept which you all need to understand. Now, from all this discussion, we get to know only one point, and that is computer can only understand zeros and one. Computer can only understand zeros and ones. There is no third concept which the computer can understand. It's either zeros and ones, nothing else. So when the computer can only understand zeros and ones, this system, this zeros and ones is known as binary. So a binary is basically, the definition of binary is that it's a base 2 number system that is made up of only two values, zeros and one. Now when I say base 2, what do I mean by base 2? Base 2 basically means, when I say base 2, this means that it can only have two options. It could either be a 1 or it could be a 0. There is no other option that exists. Now, at the start of the class, we mentioned something known as the conventional numbering system. Okay, the conventional numbering system, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that is basically known as the Denary number system. Denary. And Denary number system is basically base 10. When I say base 10, I basically mean that I have 10 possible options. And what are those 10 options? It's 0 to 9. So now if you count from 0 to 9, we have 10 options. It goes like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 values which can come under 0 to 9. And then we have a third system which I will be discussing later on, but for now you just need to understand binary and denary. So I want to ask you all, is it clear till this very moment? We haven't discussed anything, but did you guys understand the logic behind binary and like how computers operate using zeros and one? Nice. Anyone else? Yeah, perfect, perfect, perfect. Okay, so now the thing is, we don't understand binary. We only understand denary. Let's say I want to say that I have, yeah, it's basically, binary is basically the number system which a computer understands. Now I'm coming to that point. Let's say I am saying that we have 12 students in the class. Alhamdulillah, the light is on. Just a moment, let me turn on the AC, guys. It's really hot. Sound. Just a moment. So yes, basically we have 12 students in the class. Let's say, okay. Now let's say if I tell Saifullah that we have 12 students in the class, Saifullah is going to understand that yes, we have 12. But if I tell my computer that I have 12 students in the class, the computer will be like, what's 12? What students? Computer doesn't understand the terminology which we use. So we need to translate the language. Computer has its own language, which is basically known as binary. Now, let's say if I go to Turkey, I can't speak Turkish. I can only speak, let's say, English or Urdu. But I hire a translator who translates what I'm trying to say to that Turkish man, and then he can understand what I'm trying to explain. The same concept is being applied here. We have to learn. So the objective, our objective in this chapter is basically learn how to convert the conventional conventional denary system into the computer system, into computer's language, which is basically computer's language, which is basically the binary language, which is basically binary. So now how do we do that? There are several ways to do that, but we need to first understand that if we have base 10, let me just open up an example on the side, just a moment. I was just checking this yesterday. Okay, so let's say we have a value 1892. Before moving on, I want to ask you all a question. Is this a denary or a binary value? Let me know in the chat, guys, quick. Denary, good. Anyone else? Okay. And I also want to ask, why is it not binary? Okay, yes, I'm coming to that. It's basically, let me explain this. It's not binary because it's not binary. It's not binary because a binary can only have zeros and one, because a binary number, wait a second, binary number only has zeros and ones. So you see, guys, what's happening with my graphic tablet? Just a moment. Let me erase this. So we only have zeros and ones. Just a moment. Oh, I guess it got a bit of sweat onto it. Zeros and ones. Zeros and ones. You don't have anything else. Zeros and ones. Thank you guys, thank you. Okay, so basically binary numbers only has zeros and ones with it. When you see 1892 does not have zeros and ones. It has something other than that. You see, denary numbers can basically have any number from 0 to 9. So you see 1 is a number between 0 to 9. Just a moment, why isn't the AC working, guys? So we have 1892 has numbers from 0 to 9. We mentioned this earlier. Denary are numbers which include number digits from 0 to 9. If you see the number 1892, you see we have 1, which is from 0 to 9. Then we have, what's happening, guys? Then we have 8, which is again 0 to 9. यार, मसले ही हो जाते हैं guys. मसले हो जाते हैं. No, no, there isn't any limit to it. It could be any number, okay? But what's important is that we need to understand that your numbers need to be between 0 to 9. Now, if it was a binary digit, it would have only two numbers in it. It could be either 1 or it could be 0. Now, let's say if I write this number, something like 011000111. There's some lag. I don't know why it's happening, but you see, we have these numbers 0110011. Now, this is a binary digit. And why is it a binary digit? The reason behind this is that we only have either zeros in it or we have one. We don't have anything like a 7 or an 8 or a 9 or a 2, anything of that sort. Because of that very reason, because we only have two digits, it's either 0 or it's either 1, we call this binary. But looking here, you see we have 8, we have 9, we have 2, we have the digits from 0 to 9. Because we have digits from 0 to 9, which is basically the 10 numbers which we can include. Yes. Okay, so number 10. Okay, the thing is, you always look at one digit. We never look at two digits. Okay, we always look at one digit. Now, 10 could be a binary digit as well as denary. The thing is that if we look at, now this depends. Now, if it comes in a question, they will clearly mention it whether it's binary or it's denary. But usually, if it's something like they stated in the question that if it's something like this 011 double zero double one, and you see this could be termed like if someone is just saying that is it a 10? No, it's not 10. If they say it in a question that it's a binary value, then there is a different methodology to it. And if it's a denary value, yeah, then it's a 10. Now, how do we convert between them? It's really important to understand that we learn how to convert. Like, let's say you're a computer science student, right? And I want to create a short key code with you all where I want you all to maybe you guys attempt a test with me. Okay, I send you a academic test of form for the chapter number 1. You guys attempt it, and then I want to share the scores with you all. Well, perhaps I will try doing this. This is a pretty cool idea too. I will try to convert your marks into binary numbers, and then I will share those marks with you. Now, if I want to share this in a class, only the CS students would be able to understand it. It's like a key code which not everyone can crack. But as you all are the cool CS geeks, it's important that you all understand how do we convert our language into the language which the computer understands. Because if that's not the case, if you can't understand computer's language, what's the benefit of even studying CS? Like, then you're just like the normal average. You should be someone special, and you become special when you understand how does a computer work. Now, is it clear till this very moment? Okay, great, great. Okay, moving on. Now it's important that we understand how do we move from denary. Man, there is some issue with the driver, I believe, or something's denary. Just a second, let me see if it's with the graphic tablet or is it with the app. Just a moment. Minimize, minimize. Okay, it's with the app. Okay, okay, it's with the app. Wait, let me just re-screen share because I believe there's some issue with the app. Just a moment. Because the graphic tablet is working perfect. I just need to turn this off and then. Oh, I guess I was on low power mode, no turn off the low power mode. I guess I was operating on the low power mode. That might have been a reason to it. So let me just open this file again. Okay, back to the main task. Screen share. Done, 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 done. Okay, so Denary. Now, Denary is a number 10 system. Like I mentioned, we have 1892. Now, if I want to write 1892 in a manner, like if you remember in grade 4, grade 5, you used to learn the tens, thousand, hundred numbers system. Like let's say if I want to break up 1892 into the following table, like I have thousands up here, then I have hundred up here, and I have tens up here, and finally I have ones up here. If I want to break the whole thing into these four sections, how am I going to do? I will have one up here. How many hundreds do I have? I have eight hundreds, right? How many tens do I have? I have nine tens, right? And how many ones do I have? I have two ones. So I have 1000, then I have eight hundreds, then I have nine tens, and then two ones, right? This is basically your ones. This is your tens, this is your hundred, and this is your thousand. Now, what's the difference between all the four things? You can see that with every going digit, as we move from right to left, the number is being multiplied by 10. You see? So we have 10 raised to power 0, 10 raised to power 0, which is basically a 1. Then we have 10 raised to power 1, which is 10. Then we have 10 raised to power 2, which is 100. Then 10 raised to power 3, which is 1000. And let's say if I want to go further, it will be 10 raised to power 4, which will be 10,000, right? This is basically one other reason why we call this a base 10 number system, because whenever we want to find the value of something, we go like 10 raised to power the specific slot, like 10 raised to power 0 once, 10 raised to power 1 tens, 10 raised to power 2 hundreds, 10 raised to power 3 thousands, 10 raised to power 4 10,000s. Okay, but we we said that when we are discussing binary, current template, when we are discussing binary, we don't have 10. Okay, we only have two states, right? But in binary, we only have two states. We only have two states. Okay, and what are those states? It's either 0 and 1. Yeah, whatever we are discussing, it all is digits. We are only discussing digits. We are not discussing the whole big numbers. We are only discussing small digits. So we will be talking, we will be getting data, we will be converting on the basis of a single digit. Every digit in a binary, denary, or the other system which we are going to be studying later on will be having a different value. So 100 might mean 100 for a denary, but for binary it could be something else. The 0 could mean something else, the second 0 could mean something else, and finally the 1 could mean something else. So we have two states in binary. It's either 1 or we have 0. So as we have either 1 or 0, this means it's a base 2 number system, right? Base 2 number system. Now if I want to convert it into the similar base 2 manner like before, let's say I say that I have the binary number 0100. Now, why is this a binary? It's because binary because it only has zeros and ones. Exactly. It is really easy, but the issue is usually kids confuse and they find this topic pretty boring. I'm trying to explain it as easily as possible, but this is something boring, to be honest. I know you guys be thinking like, why am I studying this? But this is the foundation behind why when you open up your Instagram and you click on that story icon and then you write something and you post it, the whole methodology behind what you are typing and what you are trying to do, that has zeros and ones behind it. When you write, hey, how are you doing? This hey, how are you doing is basically converted into these zeros and ones which the computer can then understand. But now we are going to be studying that. Let's say if I get the code 0100, how am I going to understand what's the denary digit behind this? Let's say Ahmed sends me a code, okay? But he writes the code in terms of binary wording. So let's say he sends me 0100. And now I have to understand what's the number behind this. How am I going to do that? So above, we studied that if we have denary, we move with the base 10 numbers here, right? 10 raised to power 0, 10 raised to power 1, 10 raised to power 2, 10 raised to power 3. So when we are trying to find the value of every digit from right to left side, what we are trying to do, we are trying to do base raised to power the position, right? Remember, in computers, your positions always begin from zero. Whether it's programming, whether it's any sort of theoretical topic, understand. For programmers, the first element is always zero. We never start from one. Okay, like normally when we try to say that I have 10 racks, okay, 10 book slots, we always start from 1, 2, 3, 4, 5 up to 10. But in computer science, it's important to understand that the first element is always zero. We start from zero, then 1, 2, 3, 4, 5, 6. So if we have 10 slots, this basically means we have 11 slots because we also include zero in it. So from the same concept applies up here. We have the base, which is basically 10, right? We have this 10 base. And then let's say if I want to find the position, how for this specific element, it's going to be 0, 10 raised to power 0, which is basically going to be 1. Then I want it for this one. That's the first one, 0, 1. That will be 10 raised to power 1, which is basically the 10th element. Then 10 raised to power 2, which is basically the 100th element. And 10 raised to power 3, which is the third position, it's going to be 10 raised to power 3. Now, let's say if I wanted to go for the fifth position, it would have been 10 raised to power 5, which would have been 100,000, right? But in our course, we don't go to those large values. It's important also that you don't have calculators allowed in your computer science examination. So we need to work a bit on our mental working. That's really, really important because we don't have calculators in our exams. So now coming back to binary. Now, as I said previously, the formula to getting every value is basically base raised to power position, right? Now this is something which is for your ease right now, but later on you will memorize it. As you start doing these practices and everything, you will memorize it. Now if I want to find the value for the first binary digit up here, how am I going to do that? So we know binary is a base two number system, right? So if I make a table like this, 0, then 1, then 0, then 1, and I have to write the values beneath this. Okay, values. How am I going to find out what's the value for the first one? Let's assume this is the one. Okay, how am I going to find this? Now I told you we move from right to left, right to left. At least in this chapter we are going to be moving from right to left. This is our element number 0. Let me change the pen color. This is 0. This is your first element, this is your second element, and this is your third element, right? So now if I want to find the value for the first element, how am I going to do that? It's going to be base raised to power the position. So base is 2. 2 raised to power position is going to be what? 2 raised to power 0 is 1. Now I want to find it for the first one. 2 raised to power 1. 2 raised to power 1 is basically 2. So the value for the second element is going to be 2. Then 2 raised to power 2 is basically going to be 4. The value for the second element is going to be 4. Then 2 raised to power the third element, which will be 2 raised to power 3, will be 8. So the value for the third element will be 8. Now binary has, yes, exactly. Binary has specific values attached to each specific position. Now, how are we going to convert a binary number into denary number? Now, we do know that this 0101 is basically a binary number. Now, how am I going to convert this into denary? The concept behind this is that in binary, when we want to show something, we always turn the ones on. Like I mentioned this at the start, one is always referred to turning on something, right? If I want to turn on the circuit, I will be writing 1. If I want to turn it off, I will be doing it 0. Now, when I want to turn on something, and if I want to code something, if I want to like encrypt something, like I said, Ahmed, send me this binary value, I want to decrypt it. Now, how am I going to understand? The logic behind this is that now we are going to be adding the values where the binary value is 1. Now, where is the binary value 1? We have it 1 up here. Let me change the colors. we have the binary value 1 up here, and then we have the binary value 1 up here. We will be ignoring all the elements which has 0 in it. Now, what is the value for the binary values where we have 1? It's firstly 1, so we are going to be writing 1, then plus. Where is the second one? It's the second element where we have the value as 4. So the 0101 basically refers to the denary value 5. So what we understood was that 0101 is 5 in the base 10 number system or the denary number system. Yeah, turning off is 2 or Sefula, I didn't get your question. Can you repeat it? Yeah, we have 5 as the answer in the denary number system or the base 10 number system. Now, sometimes people do tend to mention 10 up here, which usually means that you are referring to denary number system. I personally would not recommend this because the reason is that in your marking schemes, you don't have a 10 written beneath the numbers. So you just don't want to confuse the examiners because sometimes examiners are very rude. They might just take it as a 510. So you should never be taking risk. Just write 5, they will understand that it's the whole thing. Okay, I'm explaining this again. Let's say, let's say I have a number 1101. This is a binary number. Okay, we have a binary number. Now, every single digit, this is one digit, this is the second digit, this is the third digit, and this is the fourth digit. All 4 of these digits have some value. All the digits have some value, some value. But we don't need to like find the value for all the digits. We only need to find the value for the digits which have been turned on. Like let's say I want to say that I want to print some number. That number is printed when I turn on, let's say for instance, this is circuit 1, this is circuit 2, this is circuit 3, this is circuit 4. Now when I turn on circuit 1, I turn on circuit 3, I turn on circuit 4, I get the number which is being denoted by 1101. Okay. Now, if I want to print this number, I have to ignore 2, right? Circuit number 2. I need to turn off circuit number 2 because if I turn on circuit number 2, it will be printing some other value. I only want the value which is being represented by 1101. Now, when we want to print the value of 1101, we need to first of all understand that what's the value of every position. Like this specific circuit or the first position has some other value, the second one has some other value, the third one has some other value. Like you see up here, we discussed that the first value is for ones, then it's tens, then it's hundreds, then finally it's 1000s. Like the fourth element 1000 is not ones, right? It's different. The number is increasing. Every specific digit is representing something else. The first digit is representing the ones, the second digit is representing the tens, the third digit is representing hundreds, and finally the fourth digit is representing 1000. Just like that, in binary, every specific digit is representing something else. The first one will be having some other value than the second one, the third one will be having some other value than the fourth one. Now firstly, the first thing is that you need to understand what's the value at each position. Now, I already mentioned that in computer science, we never start from 1. We always start from 0. We have the 0 as the first element, whether it's programming or whatever we are trying to do. For a computer scientist, you might have also seen those memes that I was waiting for a person at the first table. And so that person was sitting at table number 1, whereas I was sitting at table number 0. Now, only programmers will get this meme because for programmers, table number 0 is supposed to be the first table. Whereas for someone who is a non-CS guy, he will believe that table number 1 is the first for them, right? So we start from 0, then we have 1, then we have 2, then we have 3. Now we need to find the values, that what's the value of the 0th position. To find that, I gave you all the formula, which is base raised to power position. Now, base raised to power position, this is not a formula which you need to memorize in your exam. You will memorize all these values very easily. I will give you a shortcut to it. So no need to memorize it. It's just for your own clarification. The formula is base raised to power position, right? So the base, what number are we dealing with? We are dealing with binaries. Now, binary is 2. Yeah, exactly. 2 raised to power 0 is 1. So the 0th position of the binary value, which is the most right element, will have the value 1. When I do 2 raised to power 1, it will have 2, which means exactly it's just going to go continue. So 2 raised to power 1, it's going to be 2. So the first element will be having the value 2. When I go like 2 raised to power 2, it's going to go like 4. No worries, no worries. Number 4. And then finally 2 raised to power 3, it's going to be 8. And so if I continue on to like the fifth element, we'll be discussing that later on. But for the first four values, we understood that the zeroth element or the very first number digit on the binary section will be having the value 1, right? Then the second or the first element according to the computer will be having the value 2. The third one will be having 4. The fourth one will be having 8. Now, when I want to convert the zeros and ones, it's important that when you want to, let me write this up here, when you want to convert a binary into denary, convert a binary into denary, you will add the values, you will add the values where the binary is 1, where the binary is 1. That's the shortcut you need to memorize. Now, when we want to convert it, we need to firstly see exactly 100%. So we are just going to be adding the numbers where we have 1. So you have 1 up here, right up here, right? Then we have a 1 up here. And then finally we have a 1 up here, right? So what's the value of the first one? It's 1. 1. Then we write plus. What's the value for the next one? It's this one, right? This one. Then it's 4. 1 plus 4. Finally, what's the value for the last one? It's 8. Where did we get this 8 from? We got it from base raised to power position. It's 2 raised to power 3. Okay. So we found the value for the last one using the formula base raised to power position, which is 2 raised to power the position is 3. So 2 raised to power 3. So we got this 8 from this specific equation. Now 1 plus 4 plus 8 is 13. Perfect. A lot of people, no worries, you guys can aram se kar lona, koi masla nahi hai. Exactly. So we have 13. Is this somewhat clear? थोड़ा सा अभी भी I know this is confusing and this is a bit boring. I can explain using another example too. मैं फिर भी कर लेता हूँ. But is it clear to this very moment? Saifullah, आप भी बताओ. You had a question with it. Okay, perfect. So let me give you all a quick example. Yes, exactly. उसी तरह आपका ones, tens, 100 है, लेकिन इसके अंदर जो आपने कॉन्सेप्ट यूज करना है ना, बेसिकली वो बाइनरी के अंदर ये है कि इसमें ones, tens, 100 नहीं होते. Ones, tens, 100 exist. हाँ, उसी तरीके से आप समझ लो कि देखो आपके each position, every position has some value attached to it. So if I have the four values, I have position number 0, I have position number 1, I have position number 2, position number 3. यहाँ पे जो भी binary digits आएंगे, all the positions will have the same, like the positions value will be changed. No worries, मैं फिर explain कर लेता हूँ. All the positions will have the same value. Now, for instance, I write 0, 0, 1, 0. This is the first position. Position 1. This is your position number 2. This is your position number 3. And finally, this is your position number 4. Right? अब ये चार positions हैं. Our binary number, which is basically this 0010, this is our binary number, right? And these are the four positions we have. Position numbers 1 to position number 4. But as I said earlier, in computers, we start from 0. We start from 0. So the first position will not be 1. It will be 0. Yes, exactly. That's the shortcut I was about to tell you all. लेकिन पहले इसकी logic explain होनी जरूरी है. It's not about learning shortcuts. It's about learning the logic behind why we have such shortcuts. Then you will be able to ace your exam in the best possible manner. So as we have the binary as base 2 number system, right? We have base 2 number system, which means that the value, जो मैंने आपको पहले बताया, just memorize this value for that specific position will be, we will get that value from the formula where we have base raised to power position. Now, if it is for denary, where we said that 10, 100 and that wali thingy, it was, let's say, 10 raised to power 1. So it was 10, right? But now we are not talking about denary. It's not denary right now. We are now talking about binary. Binary only has zeros and ones. Because we can only have zeros and ones and no other state, the base is basically 2. So we go like 2 raised to power the position number. Now we have these four binary digits. Okay, we will always go from right and then we will move towards left. So we will go in this direction. Okay, now the first element, this 0, we need to find the value for this specific 0. It is going to be, this is position number 0, right? Position number 0. So it will be 2 raised to power 0, which will be basically 1. So the value for the very first 0 is 2. Sorry, 1. My bad, is 1. Then for the second one, it's 2 raised to power 1, which is basically 2. So you get it, so you get 2 up here. Then it's 2 raised to power 2 for the third one, or the second one according to the computer, it's going to be 4. And finally, it's 8. So you can learn the shortcut multiplication 1, 2, 4, 8. And then later on, it's like just doubling it. 1, 2, 4, 8, 16, 32, 64. But what's happening? We basically have this formula base raised to power position. And let's say I want to find the fifth position, which is like, let's say I want to find what's the value for the fourth position or the fifth position ideally, but according to the computer it will be fourth because we are starting from a 0, right? 0, 1, 2, 3, 4. So count it 1, 2, 3, 4, 5. So the fifth position will be having the value 2 raised to power 5. Sorry, 2 raised to power 4. So 2 raised to power 4 is 16. So the value for the fifth position is 16, right? That's the shortcut. But you need to understand that the logic behind this is basically this equation, which is base raised to power position. Now, let's do, now let's convert this number. Let's remove everything. Okay. And let's convert it. Okay. आप लोग भी साथ साथ कर लो if you got the concept. Otherwise, I'm also trying to solve the question. And let me know. We also have a 1 up here. I want your answer now. So now we need to convert this binary number into denary. Yes, practicing will make it clear. Let's say we have this binary number and we now need to convert this into a denary number. Firstly, look, do we have the values for all the specific numbers? Yes, we have the value for the 0th position is 1. For the first position, it's 2. For the second position, it's 4. For the third position, it's 8. For the fourth position, it's 16. How did we find this value? From the same base raised to power position thingy formula. Now, how am I going to convert this? We are going to convert this by firstly looking यहाँ पे ones कहाँ पे? Where are the ones? So we have a 1 up here, and then we have a 1 up here. We need to ignore all zeros. It's a key point. Ignore all the zeros. All the zeros. Zeros. We only have to look towards ones. Now, just add the values where we have a 1. We have a 1 up here, right? What value it has? It has a 2. So we will be writing 2 plus, you just need to add the values. Okay, and then where is the next one? We have a 1 up here, right? What's the value of this one? It's 16. How did I get this 16? How did I get it? I got it from the position formula. What's the position of this point? It's, this is 0 position, this is the first position, this is the second position, this is the third position, this is the fourth position. And now if I put the value equation, it's going to be 0 equals 2 raised to power 4, which basically gives me 16. So this is the 16th. The value for the fourth position is basically 16. Now 2 plus 16 is 18. Perfect. Everyone, pretty much a lot of you got a correct answer. That's really great to see. This is basically how you convert a binary number into denary number. Now let's say, let's do some other examples too. This time, let's do it 1, 1, 0, 0. We have these four. Yes, position on power. Value is equal to position on power. So now we have these 4 digits. Okay. Okay. I'm trying to explain ये जितने आप लोग इसको practice करोगे इतना ये clarify होगा. Don't worry at all. We're going slowly. There is no need to hurry. We will explain this again and again. We will be doing a lot of topical questions too, so no need to worry at all. Exactly. Now, let's say we have 1100. Firstly, we need to understand, we need to go from, what do we need to check? We need to first, step number 1, steps. Okay, let me write the steps. Number 1, find the value. Find the position values. Position values. You always write the position values above the binary number. Okay, so this is the zeroth position. Okay, zeroth position, this is zeroth, then this is first, this is second, this is third. Okay, we have our first, zeroth, first, second, third. Okay, now we need to find the value for the zeroth position. It's going to be 2 raised to power 0 1. So I'm going to be writing 1 up here. Then for the second position, which is basically the first position, 2 raised to power 1 is 2. So this is 2. For the third one, it's 2 raised to power 2, which is 4. And finally, for the last one, 2 raised to power 3, which is 8. Now, we got this clear. Now, the second one, locate all the ones. Locate the ones. Where do we have the ones? We have a 1 up here and up here. Now, as we have found the ones, we are going to ignore the zeros. We have nothing to do with the zeros. Do know, let me write it, ignore zeros. We only have to work with the ones. Consider it that the answer is hidden in the ones. The zeros clearly rejected our offer of giving us the answer. It's only the ones which said that, okay, okay, come to me, I will give you the answer. So we need to ignore the zeros. Now we have these two ones. We located the zero once, it's at the second position, and then we have a 1 at the third position. Now we just need to add the corresponding value of those ones. So what's the value of the second one, the second position one? It's 4. So 4. Then what's the value for the third one? It's 8. So 4 plus 8 is 12. Perfect. Now, let me give you all a very small example question. I want you all to solve it and just let me know the answer. I want to see, did you guys understand the concept or not? Solve this for me. 1001. What's the answer to this? 9. Perfect. Yes, yes. If you have any questions, no worries. कोई इसमें वो वाली बात नहीं है कि others are giving correct answers. I'm telling you all, this class is for someone who has never studied CS before. And at the start, I even mentioned this is the most boring chapter because people usually don't get this concept. So if you have any questions, just let me know. No worries at all. Just let me know with all the questions. Perfect. So a lot of you got the correct answer. Let me again do it for the recording. Yes, exactly. कैसे किया हमने? We found values. What's the value for the first one? It's 1. How did I get? 2 raised to power 1. This is the 0th position. What's the value for this? It's 2. Found it from this way. What's the for the third one? It's 4. For the last one, it's 8. Now locate the ones. We have a 1 up here and we have a 1 up here. Just add the two. It's 8 plus 1 equals to 9. And this is your answer in the Denary number system. So Denary, or I must say base 1. Yes, if anyone of you have a question, let me know. अगर आप लोगों ने mic on करना है तो वो भी बता दो. I can give you all the permission. 9. अब वो अभी हम आगे करेंगे, डोंट वरी. परफेक्ट. सो आप लोग को अच्छी खासी समझ आ गई है. इट्स 5:21. आई विल क्विकली एक्सप्लेन वन स्मॉल अदर थिंग which I want कि आप लोग वो भी सीख लो. Now we have studied, this is basically, what did we study? We studied binary to denary, right? We studied binary to denary. But I want you to know that it's not only concise to 4 numbers. Now I can have a binary digit like this, 1001 0001. अब इस केस में क्या करना है, where we have 8 bits. Okay, one other thing. We mentioned tens, hundreds, and all those stuff, right? But in binary, we call it bits. This is 1 bit. This is the second bit. This is third, fourth. This is the 5th bit. And finally, this is the 8th bit. So you usually would have seen this thing in your computers. When you check the size of a file, it's something as 470 KBs. Okay. So this B basically refers to bytes. Okay. Bytes, and 1 byte has basically 8 bits in it. So all these are basically memory values. We will be studying this later on, but just to explain, every single binary value has some data with it. And when we take 4 bits together, 4 bits, like let's say this 4, or the example which we were discussing above, this 4, this is basically a nibble. A nibble is basically a memory data structure which has only 4 bits in it. When we have 8 bits, something like this, where we have 8 bits, it's basically called as a byte. And when we have 1000 bytes, it's just for your own explanation, okay? 1000 byte, it becomes a 1 kilobyte and something, and it goes continuous. Yes, exactly. One nibble has 4 bits. Now when we have these numbers such as 1001 001 1001 001 one, two, three, four, five, six, seven, or 0. So let's say exactly 1,000 kilobyte, then it's 1 megabyte. And similarly, it goes, yes, exactly. It continues, then 1,000 MBs becomes a GB, 1,000 GB becomes a terabyte, and then 1,000 terabytes becomes a petabyte, and all that it continues. Okay. So coming back, if we have studied, like we have 1, 2, 4, 8. Now, if I want to find it for the fifth one, it's the same. 2 raised to power position number 4, because this 0, 1, 2, 3 position number 4, 5, 6, 7. Now 2 raised to power 4 is 16. I want you to memorize this specific concept. It's going to be doubling. Okay, 1, 2, 4, 8, 16. Then it's going to be 32. Then it's going to be 64. And finally, it's going to be 128. In your IGCSE or O level computer science, usually most of the questions are only of this length. You have to add between 1 to 128. Yes, we can continue. If I want to continue, it's going to be 256, then it's going to go 512, then it's going to be 1024, then 2048. How did I get that? I'm just multiplying the previous number. So it's multiply by 2, 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 multiply by 2. So yes, it's a very, very simple concept. Okay, kibibyte, kilobyte, that's a different story. We will be discussing that later on. There is a bit of difference in that. But for now, just consider this as bytes, okay? Bits and bytes. So, if I want to solve this very specific question, how am I going to do that? Firstly, I found the values right. I got it for the first four, and then uske baad kya hai? Just multiply. It's 1, 2, 4, 8, 16, 32, 64, 128. But multiply, 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 multiply. And now, what am I going to do? I need to locate the ones, right? So where are the ones? We have a 1 up here. We have a 1 up here. We have a 1 up here. Now, just add the corresponding value. 128 plus 16 plus 2. What's the answer? It is 146. Exactly. Perfect. 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 It's 146. So this is basically how you convert a binary number into a denary number. Now, if I give you all a test and I say that, let's say Hassan has scored 1,000 marks out of a 10 marks test. So Hassan can calculate that he got 1, 2, 4, 8. He got 8 marks out of 10. Okay, so we will be having such cool thingies in our classes where I will be testing your concepts in such cool ways. Maybe I give you your marks in such binary form and you need to calculate your scores on your own. But this is basically the main concept behind converting binary into denary. Now, what are we going to be studying tomorrow? Inshallah, tomorrow we will be studying how we convert this 146 back into 1001010. We will be learning conversion from denary into binary. Today, what we studied today, just to give you a quick overview, we studied binary to denary. Okay. This is relatively a very boring, confusing type thingy. Okay, LCM method, yeah, that's also easy, but I have something else for you. That's a shortcut which I personally use. I will also share the LCM method, but that is a bit confusing for most of the people because you don't have calculators in your exams. So the other methods can cause some errors. We will be discussing that tomorrow, but today we did binary to denary. Okay, tomorrow we are going to be doing denary to binary. Okay, denary to binary. Now, one other thing of all classes, I will be sharing. Just a moment. Let me open the official Cambridge syllabus. Just a moment. 0478 syllabus 2026. And let me also see if you guys have something new added into the syllabus, which I believe there shouldn't be. Just a moment. Mm, yeah, you don't have calculators. That's a very big issue. Very, very big issue. Okay, where do we have? Mhm. Okay, So you don't have any major changes in your syllabus. Okay, there are few changes in the programming section, but that is something which I need to tell you all, because they are telling you that there won't be marks awarded for some things and some specific things. But don't worry, उसका कोई मसला नहीं. Now coming to the main thing, let me share the screenshot with you all. um, what we studied today and आगे हम क्या पढ़ेंगे. Whatever I do, I will be sharing basically the specific section from your syllabus, because we don't want to miss anything in our syllabus. Syllabus is very very important. So how do you take a screenshot? It's like this, right? Okay, no, let me take a screenshot like this, and now let me just paste it in here. No, not from here, from here. Okay. Allah Hafiz, guys. Allah Hafiz. Never mind, guys. I don't know how do we do it, but चलो इसको हम बाद में वो कर लेते हैं. That's all for today. I'm just stopping the recording right now. And I hope you guys understood the concept behind how we need to convert binary numbers into denary numbers. And inshallah, tomorrow we will be studying how to convert denary numbers into binary numbers. And if you guys have any sort of questions, yeah, I will share all these notes and I will share some other resources with you too. Don't worry at all. And if you have any friends of yours who are planning on taking computer science, you can share the link with them. And for those who are watching the recording, the discussion forum is free and open to all. I have shared the link in the description too. You guys can join it from there. And so, really good to see you all. And Allah Hafiz. Chalo, that's really good. That's really good. Inshallah, ye to boring stuff hai. Inshallah, you're gonna learn much more engaging and cool stuff in the upcoming classes. So that's all for today, everyone. You guys can leave now. Chill, enjoy. Allah Hafiz. Yes, the Harder Education book is the book which you all should be using. कल discuss कर लेते हैं that, और मैं आप लोगों के साथ फिर PDF भी share कर लूँगा. चलो, that's all for today, guys. Take care. Bye bye. Ciao, ciao.